All right, welcome back. This session, you will probably know the names of all the people who are speaking, which is kind of interesting. Jochen will start about mapping all the things at the same time.
Thank you, Jos. Yeah, everything, everywhere, all at once. I stole that title from a movie. You should look that up. It's a weird, interesting movie. So we've got all this amazing geodata that we collected in the last 20 odd years, but we never get to see it. We only ever see the stuff that in some style on some map. So how can we see it all? Can we find a way of seeing it all? And this is what Spyglass is. This is a screenshot, but I can prove that that actually works. Here, the internet connection is good enough. This is way here in Dundee, and you can zoom in. And so where are we? Somewhere here, I think. Is that where the university is? Hold the microphone, like your life depends on it. And as you can see, you can move around over stuff, and you'll see the details coming up on the right, the tags. So everything in here is everything that's tagged in OpenStreetMap. Every node gets a black point. Every line gets every way gets a red. It gets a black line, and if you hover over it, then you see the polygon. And the blue lines and the blue dots are members of relations. So that's all that you can see. And if you have, if you go somewhere where there's multiple things, you see there's one of them will turn up. As you see on the right, the first one will be red, and all the others get this kind of yellow shadow. And then you can go through them, and there's always one is going to be highlighted. And you can choose which one you're interested in. If you just move around, then you get whatever you are pointing at. And if you are interested in something more, you click on it, and that locks so the display. And then you can use the mouse again. You can go over here and say, okay, I want to know more about this route, and maybe see this route on osm.org. Or you can zoom to where this route is, and I hope you can see it well enough. The route will show up on here. You can click on tags or keys or tags, and copy the information over OpenTag info and all that. It also has a filter built in, so if you want to see everything that has an operator, you have the filter up here for key and value, and that is not working perfectly at the moment. At the moment, if you zoom in, this is the only, all these things that you see now have an operator. But if you zoom out, you at some point, which I'll get to later on, you see everything. So that's not working perfectly yet. So this is what Spyglass is, and now get back to our regular scheduled program and look at the slides. So how this came about, you see every time somebody talks about vector tiles, there will be one person coming up in that thread and say, can't we have all the data in a vector tile? And how hard can it be? It turns out it's not hard, actually. Mapbox has done that like more than 10 years ago with the OSM QA tiles, they called them, and you can still get the GitLab, the repo, the GitHub repo, and you can find what they did there. I was involved in sort of one part of that processing software I wrote at that time, and but that was discontinued years and years ago, and they're not updated anymore. And then about 2 years ago, I think Matt Wilden who has in the US, he had vector tiles with all the data in them for Washington State, so that was a bit of a parallel development with what I at that time also started to work on. And first I called this X-ray, and there's a few things, one or more blog posts, I'm not sure, in my blog about X-ray. And at some point I decided I liked the name Spyglass better, so I moved over the name. So we can do this. We can put all the OSM data sort of in vector tiles, but how useful is that? If you do that, you get tiles that are usually too large and too slow to process for regular maps, and sort of all the usual maps that we know, and that's why things like shortbread were invented. This, what we are doing here, is not something to base normal maps on. You need more pre-processing of geometries and all that to make maps that are reasonably easy to style and all that. So the goal is not for Spyglass is not just this creating the vector tiles themselves, but creating a tool around it, and based on what the tool is doing and should do, I tweak the tiles to contain the data in a form that makes sense, and a tool for mappers to debug and all that. Goals from the beginning were, I want to have planet-wide data. It has to be it has to do minutely updated. I want to show every object that has at least one tag, and the tool should allow you to explore the data, and not something where you have to click on things and then wait for 10 minutes and there's some processing going on or so. But as you've seen, some easy exploration and therefore reasonably fast to use. As I said, it's not a goal that this is a basis for any kind of normal map, just for sort of specific this tool, and maybe for other debugging kind of maps. This is not intended for something that has a high load. This is very different from the talk that Paul talked about an hour ago or so. This is not about millions of people accessing these vector tiles or so. This is for a small community of a few people. And it's definitely not something for small screens. This does not work on a smartphone. You need a large screen to do that, and there might be ways of fixing that, but that wasn't a priority for me. And I'm not showing anything outside the Web Mercator area. So technically, I've been lying. There's not everything. There's a few things like at the South Pole that you can't see this way, but you've seen that in the live demo already. You see the stuff, you can hover over it and then highlights, and that all sort of happens in real time, and you get all this extra information, and even if you have a reasonably complicated boundary and or something like that, that's fast enough to work with that. You've seen the OSM data, what I haven't shown, but you can switch on a base map, so you can have the OSM org base map behind it if you want to. And also, because it's kind of difficult, if you see this map and it's full of black lines and everything, you can't really figure out where you are. So I decided to put boundaries in certain zoom levels. You see the boundaries and the names of places on top of the OSM data in those black and blue lines, just to get you some context, but you can switch off those layers if you don't want to see them. The architecture works like this. I'm just ingesting planet files and change files using OSM to PGSQL, goes into a database, then there's a web server that serves this data, and the web application that you have seen in JavaScript. The database contains basically tables for all tag nodes, always, all relation members. I'm storing mostly relation members, so the access is a bit faster, and with their point and line string and polygon geometries, and some others depending on what kind of object you have. currently I'm not storing attributes like usernames and change sets and all that, but that would be a small and easy change, and it just needs a bit bigger hard disk, basically, but that's easy to do. OSM to PGSQL, if you have not seen that, not used that, use a config file that is basically a Lua program. Lua is a simple sort of embeddable programming language, and that tells OSM to PGSQL which data should end up in which table, in which format, and how to transform the geometries and all of that. I'm using something called Theme Park, which is sort of an extension or framework built on top of OSM to PGSQL. It's completely written in Lua code, and it's a way of separating your configuration, your OSM to PGSQL configuration, into separate files to make them easier to understand and organized. And this means, for instance, that the boundaries that you saw, I reuse the boundaries from Shortbread. So I'm generating them myself, but I didn't have to write any code. I just said, okay, use that layer from that configuration file, and it pulls that one in, and then I have my own configurations for the other stuff. So this is one of those things that you can do with Theme Park. I encourage you to have a look at it. And OSM to PGSQL also has extensive support for post-processing and generalization of data for lower zoom level, which we'll come to in a minute. So if you're looking at the data, everything is pretty easy at high zoom levels. You just put all the data that you have in OpenStreetMap, you just put it in the tiles, and it will just work. And there's no magic going on there. For mid-zoom level, it's sort of okay-ish for my use case. I'm removing some of the small stuff if something will not show up anyway, because you have a line that's too small that you won't see it. I can remove it, maybe possibly simplify geometries a little bit. But there's still just a little bit of stuff that goes on there. But now, if you zoom out anymore, it becomes more complicated. You have to decide to leave something out, but keep other stuff. And how do you do that? Because I have a generalized tool that that wants to show everything. I can't just say, okay, maybe buildings you don't see at this zoom level, so I'm not showing them, because how would I know what a building is? I'm not looking at tags or anything like that. So doing generalization in a general form is not really possible in a good way. There's a program called Tippecanoe, which is often used for that, which is actually quite clever, doing clever things to generalize sort of data, but it's not really doesn't fit well with OpenStreetMap data, and it can't do updates anyway. So so I can't use that. So what I did instead was saying, okay, let's get rid of the filter here. So what I did instead is say, okay, we know how to do that. We did that for 2 decades. We are just rendering bitmaps. So if you zoom out, what you're seeing is in the gray here in the background, that is bitmap. So that's just raster tiles basically. And the larger stuff is then overlaid as vector tiles. So you can still click depending on where you are. Oh, I have to get rid of this. So you still get this hover effect, and you can still click on large ways or boundary lines and all that. But you see sort of in the background all the other small stuff is still there. And by the way, all of this here is directly rendered from the database. There's no caching going on. There's a PostGIS database, and I'll get to that in a minute, that renders all of this while I'm moving around here. So, where's my clicker? I thought about it, different ways of doing this, but I ended up with the raster tiles. I tried a few experiments, leaving out some of the data, and ideally it would be great if you could, in places where there's more data, it takes longer if you zoom in until you get interactive information on this less data, but that's really difficult to do and it all has to fit together. So I ended up with doing it with raster, and I have an upper limit basically on the tile size for that, and it's simple and fast, and I can do that in the database. Actually, the PostGIS PostGIS has a raster functionality in it. Yeah, it's a compromise. It's not interactive anymore, but it does work. If you ever want to do that, raster support in PostGIS is very badly documented. It took me a while to figure out how all of this works, but basically you create the extension, you do this magic thing with a band, and then you don't use the asRaster function as you might think that to turn a geometry into raster, but use the set value function, and you can create vector raster tiles in the database. Which is kind of wacky, and maybe I'm going to change that at some point. Has some drawbacks, and you can create PNGs on the fly from that in the database, and that's what I'm doing. It's kind of crazy, but sort of works. I also need GeoJSON because I want have a functionality where you can click on something and then it moves out to the whole bounding box of this object and all that, and I don't have this information in every single tile. And you can also link to Spyglass, giving the object, just like you can do on osm.org, say way / the way number, and it will get a GeoJSON and show that. And so I need a server for that, a server that can generate vector tiles and raster tiles in GeoJSON. The first try I did was using PG tilesurf for the vector tiles, and you can also generate raster tiles for it because it doesn't care, but then you have to do tricky rewrites in Nginx or something. But that it sort of works. Use PG feature surf for the GeoJSON stuff, and then have an Nginx reverse proxy in front of that, and do lots of rewrite shenanigans and stuff. And it worked, but it was a very big headache to maintain. And so I said, how hard can it be to write my own? And you'll just hear in a minute a talk from Frederick, who's also went this way of writing his own server in Go. And I thought, if Frederick can do that, I can do that also. And so I wrote a Go mini server for all these web services. And Go is a great programming language for this. It was basically invented to create web services. And so it comes with batteries included, all the things that you need. And they're the only external library that I'm using is one for accessing the database, but everything else is in there. And it's less than 400 lines of code for the server, plus 330 lines of SQL that I have, and it's SQL like that with like a templating thing, so I can do do different things in different zoom levels and stuff like that. So that's much simpler to configure and much simpler to deploy, because you generate one binary and it contains everything, and you just copy that over, and you don't need any external files, configurations, anything. Everything is baked into this one binary. Very easy to deploy. Before that, I had all sorts of problems, and you forget to copy this one file over, and you thought you did it, but you copied the other one, and then somehow it doesn't work. There's no caching. I thought about caching. I tried a little bit of caching, but in the end, it just tells the browser 5 minutes cache, and the browser will do some caching. But apart from that, at the moment, it seems to be fine. If more people are using it, maybe that needs to change. We'll see. I learned quite a bit about OSM when doing that, and sort of exploring different parts of the world. There is a lot of data now, and the world is much bigger than in a way it used to be. If some years back, if you looked at OSM data, it was mainly in Europe and Japan and the US, and now you find great data everywhere in the world. So that's a lot better. And you find a lot of garbage, like the Pacific trash vortex. This way, because you can see it doesn't have any tags that will show up on any normal map, but you can see it on Spyglass. Yeah, there's a lot of bad data in there, but there's also a lot of beautiful data in a way. That's just all the address nodes, I think, in some cities somewhere, I think in South America, that I randomly stumbled upon, did a screenshot from. So yeah, it's just fun to go around and find all the weird and wonderful places that look like maybe the aliens came down and had their landing. This is somewhere in the North Sea, and it's probably oil fields or windmill fields or something. And I found that there are a lot more relations than I had expected. This is some random place, German, Luxembourg, France border around that. And you can see everything is blue, basically. And this is all relations. That's hiking routes and borders and millions of other things. So it's quite amazing. We are moving away from just having sort of points and lines to having a very complex database with a lot of interesting data that I think few people are using and more people should do. So what's next? I still need to find a production server. It runs on the test server, OSM2 PGSQL test server that PostGIS is sponsoring. I need to figure out how to better do the filtering in small zoom levels. And I want to do sort of color-coded maps. Some people might remember the ITO maps from 15 years ago or something, where you could say, okay, I want to see all the highways, but color-coded by the tag values. That's something that should be in there. Thank you for your interest.
Time for questions. Go.
Thank you, Jochen. In your blurb on the website, it talked about being a better version of the OpenStreetMap.org data layer. What do you think would have to change before it was suitable to replace the data layer?
So one thing is, I'm using MapLibre for all of this, so that's something, and you probably need MapLibre because it's just much faster than the other rendering, than leaflet or open layers. So that I think would need to change, and obviously it needs sort of more baking and all that. So there's a few things in there. At the moment, I don't re-render the low zoom levels, and it's just me needing to take 15 minutes hooking up the expire thing properly and all that, but it needs to be done, and we need some more experience with it, and it can be in some places it's slower than in Dundee if there's a lot of data, and so that it needs some more tuning, I think, sort of what exactly in what zoom level do we have vector tiles, and when do we start the raster tiles, these kind of things. But apart from that, it does work. And please try it all out and open issues if you see problems and all that.
You mentioned that in some places it's slower than Dundee. Are there places that you found where it's slower than the OSM.org data layer?
No, I mean, the thing is with the data layer, you have to be zoomed in quite a lot to actually get something. So it's difficult to compare, compare that. But I don't think it will be slower anywhere. Yeah. Any other questions? Yes.
Sorry, I don't have a question, but this is one of the coolest things I've seen at this conference. I'm really impressed. So thanks for sharing.
Thank you.
I had a question. It looks really beautiful and quite sort of designy. Do you have any design experience, or is it just chance?
No, I don't have any design experience. I've been, creating websites for a long time, and I mean, for me, that's important. It's an important part of the experience that it looks nice. And my experience is just I write some functionality and then I try to make it more beautiful and more workable, and then and easy to use and all that. Then I switch between coding and trying to make it look reasonably nice, and that never finishes. There's always something, a little bit of tiny thing that you can do a little bit better. And this is all just handwritten HTML and handwritten CSS that does that. But I spend a lot of time to tweak that because it's difficult, especially with the interaction, to get this right. When you click on something, what exactly happens if there's multiple things, as you saw, how to do that. And yeah, it's the small things that make it work. And for instance, here if you click on something, you see there's one tag that is highlighted in green, boundary at minute. So that's the most important tag is highlighted with this background, so it's easier to find. And the name is written in with a different font, or with a fat font, so it's easier to see that. And this is just for me using it while developing it all the time and figuring out. I was searching for what is this thing that I'm just looking at, and found out, okay, I need some way of doing that. And yeah, just keep iterating and trying to do that better. Yeah.
A little less than 2 years ago, we talked about generalization in Hamburg at the PostGIS event. And at that time, I get the idea that there will be some more functionality in OSM to PGSQL. Today, you told us it's not generally used. Is it only in the aspect of the new tool you have developed, or is it in general?
So I'm using some functionality that's in OSM to PGSQL for generalization. I'm using here that runs this raster generation, but that's very different from what you normally use with generalization. And so what I meant with what I said there is doing generalization in a general way is basically impossible. You have to sort of, for each type of feature that you have to use a different algorithm and different ways of generalization. And because I can't know this, because I want to show everything in OpenStreetMap, I mean, there's a little bit of specialization in there with like polygons, and do different things for polygons than for line strings, for instance. But I can't differentiate forest from a building, because for me that's both a polygon, so I can't use generalization algorithms for that. So I'm falling back to this raster tile generation. But this functionality, there is functionality for that in OSM to PGSQL, and other people are using that. So there's a long way to go. There's lots of things that we still need, but there is some stuff in there.
Well, thank you very much. That was
Thank you.
really good.